Hello everyone, this is Mikel Garcia. I'm the CTO and co-founder at Rokubun, and today we are going to talk about a project that has been funded by ESA. It's called the AMIC and has been executed, or it's being executed because it's not yet finished yet. It's been executed by Rokubun as the prime, along with the Abdus Salam International Center for Theoretical Physics. The AMIC project basically consists in the deployment of several affordable GNSS receivers in areas where it's difficult to reach or they are remote, and therefore they are difficult to maintain. This presentation is going to be done using the data labs that are hosted in the GNSS Science Support Centre webpage, which, by the way, also hosts the data that is generated by those receivers of the AMIC project. So this integrated environment makes it very convenient for that to analyze the data from this network. So therefore, it's basically important if you have an account for the GSSC. If you don't, go to the login page and then make one account. And once you have it, just log in with your account. The account is free, so it's a very convenient tool. Once you have it, just go ahead and go into the data labs. In the data labs, you'll see various tools that you can use. We are going to use the one for AMIC. So go ahead and look at the one that it's global AMIC, ionospheric monitoring with data from affordable GNSS receivers. Click the play button. Here you have to launch. And then this will basically create a workspace where all the scripts, notebooks that have been developed for this presentation are available for you. So once you have it, now go ahead and go to the My Workspace. Okay, and in my workspace you will have several files, right? So first go to the README. That's basically the entry point. I'll give details on the following, don't worry. Okay, so first let me give you a description of the project. For that, let's go to the main AMIC notebook, which is in this README. Okay, let's go here, and then let's collapse this so we have more space. So what is basically the purpose of the AMIC project, right? So it's basically the processing of GNSS data from affordable receivers for ionospheric monitoring and densifying this the amount of data that we have in order to fulfill that goal. So why do we need another network? As you know, there are plenty of GNSS networks and course stations spread worldwide. We have IGS, we have UREF, we have dense networks in Japan, we have dense networks in California, etc. But there are still areas in the world that they have a clear lack of GNSS receivers, and these are basically remote areas or areas that are difficult to access, like deserts. In that case, deploying a GNSS receiver is complicated, and even more if the price tag of this receiver is expensive. So the hosting institutions might be reluctant to actually make the purchase to lose this receiver because it has been damaged or because it's not operational, and going to maintain the device is very expensive. So that's basically the main purpose of AMIC. So deployment of affordable receivers that will reduce the reluctance of deploying them in remote areas. So this AMIC project basically deploys the network of receivers, and these receivers they have to have connectivity, obviously, and they push the data into the GNSS Science Support Centre webpage, right, under the AMIC dataset. The collection is Acorn. That AMIC is the project, Acorn is the network that results from the project, and so all the data is grouped in that collection. The data is public and is free. So, but the only requirement is that you have to register into the webpage to download and process. So we mentioned before affordable. We used the term affordable before. The receivers that are used in the AMIC project is basically an integration that has been done in Rokubun that basically contains uBlock Z F9P plus an application processor. and everything is packaged in this casing that you're seeing before, and the antenna that we are using is similar to a low affordable one like this Talisman antenna. We're actually using one, but it's on the same characteristics. It's not a geodetic antenna, it's not a choke ring, but it's still decent for our purpose. So this receiver is affordable. We are talking about 1 to 2K, and they can be replaced easily if one gets damaged. Then for this project, the receivers come pre-configured so that the host institutions only have to take care of plugging it into the power grid and giving some Wi-Fi connectivity to transfer the data. That's all it needs. Then it comes pre-configured with the name of the receiver, and that it will identify the data to be pushed, as well as the country of the data. This is required for the RINEX naming, which is the format that it's being used to transfer the data. These RINEX files have a file rotation of 15 minutes, and they are high rate data, so it's a 1 second data. Whenever a RINEX file is complete, has been built, if there is connectivity, it's pushed into the ESA GSS servers. If not, they are stored locally until connectivity is present. In that case, then it will push all the files and then remove them from the internal memory to save space for later on. Okay, so as I was mentioning before, this series of workshops or sessions for this workshop are basically based on the data labs, which are Jupyter notebooks. So you will need several knowledge or prerequisites to follow this workshop. One is a certain familiarity with basic GNSS concepts. Basically, you have to know what is a pseudo range, what are possible combinations between pseudo ranges, like the ionospheric free combination, etc. So, and then you will have to have at least a basic knowledge of Python programming language, because it's the main language that we are going to use, along with some specific libraries, which are the NumPy and Pandas libraries. They are very powerful libraries for data processing and data massaging. And the contents of this workshop is basically divided in 3 modules. One is getting AMIC data into the notebook. That's what we are going to do in this session now. So we have a bunch of data, wealth of data from the AMIC project. So how do we download it? How do we process it? So I'm going to show you how to do it. And also in subsequent sessions of this workshop, we are going to assess which is the noise from these affordable receivers that we are using, and how can you use them to actually make some science out of it. In that case is how can we compute the rate of tech indicator, which is an indication of the scintillation events for the ionosphere. Okay, so let's go into the first part of this workshop, so getting data. So what you are going to learn here. So you are going to learn on how to fetch data, RINEX data in the form of Pandas data frame, and also how to join multiple RINEX files into a single data frame that we can use later for the subsequent processes. So the first thing that we are going to do is install a package that has been developed for this workshop. Vale? Let's see how this looks like. This package basically has a source and has a setup.py. So basically what this pip install dot does is installs this source package along with the required dependencies. This code is available to you once you install your workspace. So therefore, you can have access to the code, to the source code, and check what is the implementation of the different functions that are in there. In particular, we are seeing how to get the data. To do that, let's import the module as long as some other additional data, or sorry, additional packages, and then we can now get the files. So as I mentioned before, the AMIC receivers push the data into the ESA portal. The data is in the form of RINEX3 files that are HATANAC and gzip compressed. So time rotation of 15 minutes, and we're talking about high sampling rate, so 1 second data. Then we can download daily files using the AMIC data get method that it's in the source package that we just installed before. right? So you can actually, because we have imported, we can now type the help of this function, right? So the get the AMIC data for a specific receiver and date, and here it basically includes a description of the required input. So now what we can do is go ahead and then get the data for the AMIC data A001, that's the name of the receiver we want to fetch, and for that date, 31st of March 2024. Max files is because we are going to limit our fetching to 10 files. This code, unfortunately, is not super optimized, and therefore the parsing of the RINEX file and then conversion to data frame could be improved a little bit. But okay, with the 10 files is already reasonable. Okay, this is finished. So now what we can do, so df RINEX is a data frame, pandas data frame. So we can actually have a look on how does this data frame look like. With the head command, basically what you're doing is printing out some preview of the first rows. This, as you can see, is basically it resembles a CSV file. No, it's a table of data. Each row contains information on the epoch, constellation, satellite, and channel. The signal is basically a combination of the satellite and channel. We are adding this into the data frame as a convenient column to index the data, quickly search without the hassle of having to look or build conditions on two different columns. And here we have also the range, phase, Doppler, SNR, and some flags, measurement flags from outliers, etc. And then a cycle sleep indicator, which comes very handy when we want to make combinations of data that involve the phase. Okay. So as you can see, the loading of the data is rather slow. So what we are going to do is save this data into a CSV, right? That's what this command is doing. So we could make a df RINEX to CSV, and then we will store it into a AMIC sample CSV file. If we have a look at it here, we can double click. You can hide this. And then basically what you will see is a CSV, a simple CSV that you can import it in subsequent notebooks. That's what we are going to do, or you can open it with an Excel or any other tool that you have. With this, this step basically saves us a lot of time for the next two modules that we are going to do in the next sessions. So basically, instead of loading the RINEX, we are going to load the AMIC sample, right? So you could do, for instance, as an exercise, download data from A003, for instance, or A010, and any other data that you want, and then start playing with it. With this, basically, it finishes this first part of the workshop, and then in the second and the third, we are actually going to use other notebooks to actually process data and get some meaningful information. Okay, so far, thanks for your time, and then let's see in the second session. Bye.